Please be seated. Good afternoon. My name is Julio Ottino. I'm the Dean of the Robert R. McCormick School of Engineering and Applied Science. I welcome all of you to our annual Master's Degree Recognition Ceremony. It's an honor to have so many friends and family here to celebrate the graduation of our master's students, who in many cases have made special sacrifices beyond our other graduate students, either by putting their careers on hold while pursuing a full-time degree, or by combining substantial part-time study with full-time careers. It has been an honor for us to participate in your education. I would like to welcome the parents, spouses, family, and friends to our master's candidates who have shared in the many sacrifices, challenges, and successes of graduate education. Let's give all of them a round of applause. Graduates, over the course of your education, you have learned timeless skills that resist obsolescence, skills that have empowered you to become a leader in your field. Maybe it is how to think in terms of systems and interrelations, or maybe it's design thinking skills that help you how to solve problems. Whether or not you are starting new careers or moving up in current ones, now you hold the significant advantage of knowing how to solve the right problem behind the perceived problem, finding the right question behind complicated issues, and knowing that finding the right question is sometimes more important than finding the right answer. There is no big prize for finding the right answer, what happens to be the wrong question. You will take these skills wherever you go. One of the best things of our master's programs is that our students represent a broad range of ages, backgrounds, and careers. You have all brought a diversity of thought and experience to your master's education, and you will leave not only with a degree, but also as a member of the community with the best minds in your fields. This network will stay with you throughout your entire career. I want to thank you, our graduates, for selecting the McCormick School of Engineering to pursue your master's degree. Our faculty members are proud of your accomplishments, and we wish you the greatest success in your future career. Congratulations to all of you. Now, I would like to introduce our convocation speaker. Bob Gariano is the founder of Robert Gariano Associates, a nationally recognized executive search firm. Previously, he served as the global sector leader for Russell Reynolds Associates, and prior to that, he worked for GE. He was recruited by Jack Welch in several capacities, including country manager for GE Canada and director of strategic planning for GE Europe. He is really broadly educated, to say the least. He has a bachelor's in fine arts from Carnegie Mellon University, an MBA from the University of Massachusetts, Eisenberg School, and a master's of liberal arts from the University of Chicago. And to top it off, a master's in information technology from Northwestern University. It is my distinct pleasure to welcome Bob Gariano.
Thank you, Dean Ottino. Congratulations to all the graduates here and to your families too. You've accomplished something very special. I think some of you already probably run technical groups, and some of you will run technical groups in the future, and that's what I'd like to talk to you about today. Running teams of technical people is perhaps one of the most difficult and most important roles in a modern company. Technical leaders must combine a lot of the things that make the McCormick program so special: business acumen and leadership, right and left brains, as Dean Ottino would say, in addition to the technical content that you've all been studying. So it's a very difficult, important role. It takes a special person to do this, and it always reminds me of one of my favorite stories, which I'd like to tell you today about technical leadership and how it can benefit the business. In the late 1950s, Bell Labs was experimenting with systems to relay microwaves over long distances. High-frequency microwaves could be used to transmit enormous amounts of information. If you're wondering how that all works, you can ask Professor C.C. Lee or Professor Honig at another time about how higher frequency means more information. There's just one big problem with microwaves. Microwaves travel in a line of sight. Unlike other lower frequency waves, they don't diffract around mountains, they don't follow the ground as in ground waves, and they don't reflect off the upper atmosphere. So microwave communication links have to face this line of sight. They can't look over the horizon. Now, Bell Labs is going to get around this with a very interesting idea, and it may be surprising to you when I describe it to you. They were going to have high-altitude tethered metallic balloons. This is true. They were going to deploy these balloons, and they were going to bounce the wireless communications, the microwaves, off these balloons, and then take them across continents and maybe even across oceans in that way. This plan had one difficulty, and that is you had to have big, sensitive microwave antenna to receive the echoes coming off the balloons. As part of this effort, Bell Labs built an enormous and highly sensitive microwave antenna at Homedale, New Jersey, just outside of New York City. Of course, this was kind of a short-lived scheme, because by the 1960s, missile technology and the advent of geosynchronous satellites being lifted off of those missiles allowed another method for transmitting this information. The first Telstar satellites in the early 1960s took the microwave transmissions from the ground, received them, amplified them, and then concentrated them back to the ground. So it was a much better way, of course, than aluminized balloons. Even though that first Telstar satellite could only handle about 600 telephone calls at one time, it was clearly the breakthrough that Bell Labs needed. Suddenly, to all the people at Bell Labs, this idea of using a metallized balloon to bounce signals off of looked almost laughable. It certainly was archaic. Without the need for metallized balloons, there was no need for super-sensitive microwave antennas anymore. And so the big Homedale antenna was mothballed, was wrapped up and put away. But this obsolete antenna caught the eye of a couple of Bell Lab researchers, Arno Penzias and Robert Wilson. Decided that they could use that instrument to study microwave radiation coming and hitting the Earth from outer space. Now, most of their bosses at Bell Labs didn't think much of this idea. They didn't think there was any practical value in studying extremely low-strength microwave radiation that was really a part of an obsolete balloon-based communication system. But the big guys at Bell Lab, they grudgingly gave their research supervisor okay and said, here's the keys to the old antenna. Do what you will. First of all, I should tell you, these two researchers were kind of an odd couple to begin with. Penzias was born in Munich in 1933. In 1939, he and his family were forcibly transported to Poland. Fearing the worst from the Nazi regime, the family then fled to the U.S. They settled in a small apartment in New York City. Penzias became an outstanding student, went on and studied physics at the City College of New York, and then got his PhD at Columbia. In contrast, his friend and his partner in this effort, Robert Wilson, was a Texan. He grew up around the Texas oil fields. His dad was a drilling engineer. He'd always was fascinated in this new idea of electronics, even as a kid. So he went to Rice to get his undergraduate degree, and then went out to Caltech for his graduate work. Diverse as these two were, they were thrown together by the Bell organization, and they became fast friends. So they set out to see what they could do with this Homedale antenna, even though it was mothballed. They decided to study microwaves in a wavelength of 7 centimeters. There was a reason they decided that. 7 centimeters was the old standard that was used for broadcast television. So a lot was known about these wavelengths. They had one problem. For all the precautions and careful experimentation they did, they just couldn't get this old antenna to work properly. They were surprised they kept getting aberrant signals into the instrument. It was a consistent part of every measurement they made. They couldn't get their instrument zeroed out. It kept registering some level of interference, some background noise. It was really frustrating to them. So they began a painstaking process to find out what they were doing wrong. First, they pointed the antenna in different regions of the sky to see if there was a variability. Maybe there was some astronomical event that was causing this. Didn't help. They patiently waited while the Earth went through the orbit, through its orbit around the sun, and that didn't change things. They eliminated signals that might be coming from nearby New York City, which was right across the river. That didn't change anything. They even went so far as to decide, well, maybe while it was mothballed and the pigeons were nesting in the antenna, the debris was causing this problem. So they climbed up there and cleaned out all the pigeon debris. Still no answer. About this time, and unknown to Penzias and Wilson, there was a professor at Princeton named Robert Dick. He was a researcher, and his specialty was investigating theories about the beginnings of our universe. Dick agreed with certain other physicists that our universe had started with a big bang some 15 billion years ago. There was one obstacle that Robert Dick faced, though, in convincing people of the validity of this theory. If the theory is to make any sense at all, there must be some residual signal from this Big Bang. It could not have completely disappeared altogether. So he was looking but couldn't find anything. At that time, and just by coincidence, Penzias and Wilson showed up at his lab. They thought they had some real information about how to make this antenna behave. When Dr. Dick saw the data that Penzias and Wilson brought from Homedale, he was floored. Dick immediately recognized that the noise that the two Bell Labs researchers were hearing in the Homedale antenna wasn't an aberration at all. The faint noise that the two Bell Labs researchers were hearing from their instrument was in fact the echo that he was looking for, the echo of the Big Bang that was still rattling around our universe. The universe, it turned out, was filled with this very faint cosmic background radiation. In 1978, Penzias and Wilson, the two Bell Lab researchers, were awarded the Nobel Prize, which they shared, for physics, for discovering cosmic background radiation. Their work was the final evidence needed to legitimize our modern theory of cosmology. Cosmic background radiation is one of the pillars that support physicists' ideas today about how our universe began. Not only that, the work that Penzias and Wilson did turned out to be instrumental in allowing Bell and their parent company to build high-capacity wireless satellite-based networks for communications. It cemented the Bell system as the leader in that rapidly expanding market. The notoriety of their Nobel Prize attracted other top technical experts to the Bell organization and further built their competitive advantage. Quite a nice little payoff for what Bell Labs invested in 2 young researchers and an obsolete antenna system. But I want you to think for a minute. I want you to think about what the top brass at Bell Labs was thinking when they looked out the window and saw 2 of their young scientists up on a ladder climbing into an antenna with brooms in their hands to sweep pigeon droppings out of an antenna. It must have taken some remarkable political air cover to allow the 2 to continue their work, while other researchers were working on the more practical ideas of microwave transmissions. This is my favorite story because the lesson is so simple. New knowledge and new inventions almost never come in a straight line process. The process is a circuitous affair with unexpected outcomes. There may be very little to report to management for monthly reviews or for quarterly earnings releases. But every successful technology company that I know gives their best and brightest researchers and scientists the elbow room and the resources to pursue new ideas that don't seem to have an immediate payoff. For Penzias and Wilson, Bell Labs management provided this room for them. In the end, their work allowed us to explain how our universe began. I hope each of you will take one message this afternoon from this short story. I hope each of you will show the same courage to give your best technical people on your teams the elbow room to make their discoveries. That will take courage and it'll take tenacity. But what your people discover by getting those resources, they might just invent something that will turn into the most valuable and unexpected advances for your business. Thank you.
We just get the right thing. Okay, thank you, Bob. And I want to echo what he said about placing bets at the periphery. Every bet is at the core, you may miss on fantastic opportunities. You don't have to bet making a bet on the whole house, but you should always have something on the side, because what is core now, what makes you great now, will not be what will make you great in the future. So you always have to be looking at, have good peripheral vision and make investments on things that have uncertain payoffs. Now, I would like to introduce Senior Associate Dean Rich Lepto, who will introduce the graduates by program.
Good afternoon. We'll continue our ceremony recognizing our master's candidates, graduates. Please approach the stage as you're guided by a member of our staff. I'll read each graduate's name, and then you will proceed across the stage and be congratulated by the program director. We have our professional photographer taking photos of each graduate. We'll begin with graduates from the Master of Science in Biotechnology program. Faiza Fatima Afsar Ali. Lachelle Brooks. You do. Anuja Ganesan. Alexander Getty. Nicolette Gregor. Jean Marie Laverne. Yu-Chen Theodore Lee. Catherine Lin. Mingjun Liu. Sana Ma. Sejul Mystery. Brian Oyang. Ritwikwa Sansharma. Sneha Shankar. Mohammed Nadeem Sharif. Sauramini Shivadi. Shuhan Shi. Jake Vitrovsky. Kenneth Wang. Xiao Wei. Stephanie Weigel. Yachi Wu. Bettina Wunderlich. Yachi Zhang. Xiaotian Zhao. Sean Zhao. We now move to the Master of Engineering Management program. Amber Agarwal. Mark Bernardi Rice. Carmelo Butari. Abimanyu Brimojan Chilangi. Hemant Desale. Catherine Fath Dispinoy. Sakun Janardhana Rao Gaikwad. Yuji Harada. Arturo Hernandez. Makarund Kavakar. Yash Kaushik. Ranjani Devi Kalur. Swapnil Ramash Latad. David D. Lowe. Mukai Liu. Lisa M. Myers. Andrew J. Knockenberg. Jeffrey B. Narducci. Oswaldo Antonio Noriega. Ty Willis Olson. Sandeep Puvar. Ansan Ali Qureshi. Vignesh Ramasamy. Geneva Daniel Pandian Samuel. Weston Schrammick. Anwar Nicholas Stevens. David J. Turnquist. Zenghong Wu. Timothy Tycoon Yoon. We move next to the Master of Science in Information Technology. Christian Brofaneschi. Barry H. Chu. Chinzareg Davatsaran. Kenneth J. Fabsick. Barry M. Friedman. Charles Truett Garrett. Amanda Go. Jianyan Hao. Danye Jar. Yusuf Kamel. Raheel Kaul. Sinbo Liu. Michael R. Mokadansky. Sujana Perumal. Catherine Petranek. Scott Allen Poole. Abhishek Raj. Saibal Roy. Harshvardhan Shukla. Rich Volkanet. Eric L. Wilberscheid. We now move to the Master of Product Design and Development Management program. Lauren A. April. Jennifer Billings. Jerry Culver. Karen M. Durr. Tracy Jean Dubas. Oleg Yevdokimov. Sonia Hawley. Allison M. Hibnick. Rachel Christner Howard. Philip F. Khalil. Yoon Young Kim. Heather Koenigs. Noelle Marie Christie. Brandon Carl Loss. Bridget McMullen. Jennifer C. McRae. Matt Medhat. Anna Elizabeth Mollenkopf. Tyler Scott Mollenkopf. Trevor Mackenzie Morgan. Cecilia Ann Wolford Myers. Daniel Thomas Nering. John W. Parr. Prati Patel. Maria Cristobal Ramos Tirado. Rajarajan Ravichandran. Joanna Rosenbaum. Erica Julia Ruiz. Patricia Tate. Rex L. Vargas. Samantha Wang. Doug Weaver. Benjamin Thomas White. Christina Whitehouse. John Wilds. Sarah Weichert Wood. We now move to the Master of Project Management program. Rudy Alakhaj. Jose Antonio Apestegi. Amaury Carbonneau. C. Chen. Chloe Gabriella Frederique Delaunay. John H. Gill. Bao He. Jennifer Iverson. Mathilde Jarrett. Sultan Katranji. Wenjing Ma. Marilia Santos Marcon. Julia Moragas. Shaylee Neelish Kumar Patel. Tianyi Shen. Rehab Yahya Shinawi. Hanin Shinawi. Pradit Tanya Sharon. Guanghong Tai. Zhan Tanyo Wang. Yifeng Zhu. We move now to the Master of Science in Robotics. Adam Pollack. And we now move to the Department of Electrical Engineering and Computer Science. Kashil Jitranjakumar Patel. This completes the conferral of master's degrees.
Thank you. I again would like to congratulate on behalf of all the faculty to all the graduates with another round of applause. So today marks an important day in your careers and in your life. Your degree is a significant accomplishment, and today we are giving value by conferring a degree, which is a significant achievement. But from now onwards, you will give value to us. The tables turn, all good things that you do in life, we will bask in the glory of your achievements, okay? We are only as good as the people that we produce. The entire reputation of McCormick rests on you now. And although your careers will take you far from campus, we hope to see and hear you on a frequent basis. As alumni, let me repeat this, you are the source of our value, okay? We are only as good as the people we produce. We are proud of you. We are eager to see what you will accomplish. Congratulations again. Now I ask that friends and family remain in your places until the faculty and graduates recess. Will the graduates please stand as the procession begins?
you.